Welcome to the second video, which is predicting the products and balancing single replacement reactions. Okay, and in any single replacement reaction, what happens is you have a non-metal bonded to a. Let's reverse that. Yes, here we go. It's the summer. So you have a metal. Remember, metals come first because they're positive, and cats are great. So positive ions are cations. So we have a metal bonded to some non-metal, and then let's say you have a metal by itself. Okay, what's going to happen? And then we'll call this metal 1 and metal 2. Okay? What's going to happen is the metal is going to try to kick out the other metal. So let's say it could kick it out. We'll talk about why we need to use this in a second. Okay, so let's say it could kick it out. You would get the metal 2, which would bonded to the non-metal, and then metal 1 would be all by itself. Now you could also do it this way, where you have the same thing, metal 1, now non-metal 1, and then non-metal 2. In this case, the non-metal is going to kick out the other non-metal. So metal 1 would now be with non-metal 2, and non-metal 1 would be all by itself. Now, these reactions only occur if the element doing the kicking out is more reactive than the one that it's kicking out. And that's why on the side, this is from your honors formula sheet, we have this reactivity series. The ones on the top are the most reactive, and the ones on the bottom are the least reactive. You do not need to memorize this activity series. If you need it, they'll give it to you. But a lot of times, you don't even need it in the problems. In the problems that I did over the summer, I had to think about this maybe 3 or 4 times. But the way they asked the question, you didn't need this table. Or the way they posed the question, you didn't need it. All right. So again, when balancing any equation, you need to first write the formulas. So, just so you know that this AQ means dissolved in water, and S means solid. So here we're reacting a solution of copper hydroxide dissolved in water with aluminum solid. So we're first going to write the formula. So copper, this is telling you that it's +2. Hydroxide, which we need to memorize, is OH, and its charge is -1. Okay, so we're going to write the formula. Copper, OH, that 1 comes down here, this 1 is coming here, and this 2 is coming here. And if you remember, I didn't get a car when I was a high school student because I got a 99 on the chemistry just because you need to put parentheses around the polyatomic ion when the number is outside. Okay? And then we're going to react that with aluminum solid, and aluminum is just this. So now we have to see here if aluminum can take out copper. So let's look at our table up here. And so the question is aluminum more reactive than copper? Well, here's aluminum, and here's copper, so aluminum's higher, so that means it's more reactive, so it can. So then the first thing we do is we kick it out. We don't carry over any little numbers, okay? So aluminum is now with hydroxide, and then copper got kicked out. No little numbers are carried over. The only time you would carry little numbers over is if they were in the parentheses or part of the polyatomic. Okay, so now we have 2 more things that we got to do here. We have to check if this formula is right, and we have to check if this one's a diatomic. So this one, aluminum +3, hydroxide is -1. We got to flip it. We don't write 1. This goes in parentheses, and we get a 3. And then copper is not one of the diatomics, so it stays by itself. It doesn't need a 2 here. Last but not least, we got to balance the equation. We have a problem with our hydroxides. We have a 2-3 situation with our hydroxides. 2, 3. So we have to put a 3 here, and a 2 here, and that messed up our aluminum, so we got to put a 2 here. And then this 3 messed up our copper, so we got to put a 3 here. Now our reaction is balanced. All right, let's do B. So B, we have lead 2 bromide. So lead, which you have to memorize, is Pb with a +2 charge. I'm telling you by that. And bromide is Br, and it's always -1. Crisscross, you get Pb, Br2. Remember, this number comes down here, this number comes down there, and you drop the signs. And mercury, which you also have to memorize, is Hg. Okay, now, we're going to see if this occurs. Remember, Hg is a metal. It's going to kick out the other metal, lead. So let's see if this can happen. Can mercury kick out lead? Well, here's mercury, and here's lead. Since mercury is lower on the table than lead, that means it's less reactive, and this reaction doesn't occur. So we write NR. Okay. So we have our last reaction here, which is ammonium bromide. Ammonium's a polyatomic ion. It's NH4. Gotta memorize those polyatomic ions. I don't know what else to tell you. Alright, so +1, and bromine, which is -1. So NH4 Br. And we're reacting with chlorine. But you have to remember that chlorine is one of those diatomics. It doesn't like to be by itself in nature, so it gets a 2. Okay. Now if we look at this, chlorine's a nonmetal, and it's going to kick out the other nonmetal, which is bromine. So NH4 is now going to be with chlorine, and Br is by itself. Now, actually I have to take a step back. Why can this happen? Okay. So for nonmetals, if we take a look at our periodic table that we have here, for nonmetals, the more closer to F you are, or the more electronegative you are, really, the more reactive you are. So if we take a look here, chlorine is closer to F than bromine, so therefore chlorine can kick out bromine. But again, it's still reactivity, but it's based on electronegativity, and elements closest to F have the highest electronegativity, because F is the most electronegative element on the periodic table. So here we have 2 more things. Whenever you're at this step, you have 2 more things left to do. Check the formula of the new compound that you formed, and check for diatomics. So ammonium, which you have to memorize, is +1. I guess you could look at the table now, but it's +1. And chlorine is -1. Those cancel out. You don't got to do anything. Bromine's a biatomic. Needs 2. All right. Then last but not least, we got balance. So we have a bromine problem. We have 2 bromines here, and the 1 bromine here, so we got to put 2. And then this 2 affects the ammoniums. We have to put a 2 there, and that 2 affects the chlorines. So we're all good. All right. So that is the end of the single replacement video. Enjoy doing the summer assignment questions.